Hi, so if you've seen any of my previous videos, you know that I'm kind of obsessed with one thing, and that's solenoids! But it's because of their magical and mysterious properties when fed current. But does anyone really know how these things work? I mean, should we be afraid of them? The answer is no and yes. The only thing I can really compare it to is this thing. Seriously, how? I'm of course kidding. I explained how they work in this one. But just as a recap, when coils are fed current, they create a magnetic field that acts upon whatever magnetic material is inside the coil. So our coil is wrapped this way. So according to the right-hand rule here, our current is flowing this way. So our magnetic north is on this end of the coil. So north, south. And this creates either an attractive or repulsive force on our little buddy here, depending on which way this thing goes in. Okay, Sophie, roll the intro, please. Okay, great. So we know how a coil works now. Why don't we get on some kind of government watch list already? Well, before we can build our coil gun, we have a big problem to deal with. So let's say this is the north end of our magnet, and when I power this on, north end is over here. Well, we don't have to pretend like that would happen. That would happen. When it first goes in, the north side of the magnet is attracted to the south side of the coil, and it keeps going in, and then as soon as it reaches the north side of the coil, it stops, or it slows down, because it is automatically repelled now by the north side of the coil, and then it oscillates back and forth until it comes to a stop. So that is our problem number one. This is the circuit that I designed to get around this problem. So at the end of this coil, I'm going to have a Hall effect sensor. It's basically a switch that is activated by a magnetic field. So as soon as a Hall effect sensor senses, I think it's the north side of a magnet, it sends a high signal to my Arduino, letting my Arduino know that a magnet is in front of it. So I have one end of my coil just hooked up to positive, but I have the other end of the coil controlled by a NPN transistor. So an NPN transistor has three components, and they are the collector, which takes in the positive current, the base, which is supplied by my Arduino, and it's just a small bit of positive current, and the emitter, which goes directly to ground. So my transistor in this case is either going to allow the current to go to ground, or it is going to block it, turning the coil off. The reason that I wanted that to happen is if I turn the solenoid off as soon as this thing reaches top speed, instead of oscillating inside the barrel, it'll shoot out. So that is what we want. Alright, let's see what it looks like. I have the thing set at 10 volts at 1 amp, so I don't explode any transistors here. So before I run this thing, I'm just going to show you what it looks like without any kind of intervention, to show you that I'm not just lying to your faces. It just doesn't go anywhere. Okay, take two with the circuit running. I'm going to do same voltage and current. Haha, it worked! And it waits 3 seconds to turn it back on, because programming. Now the next step is wrapping the coils.
Why are we still here? Just to suffer. Every night, I can feel my leg.
No, but seriously, that scene made my heart fall out of my butt. Well, after wrapping the coils is going to come setting up the battery and then setting up the sensors, which is going to be kind of easy, I think, hopefully. Well, let's get started. So, fast forward a week, I'm finally done coiling this thing. I got stages 1, 2, and 3, and I made some changes to the circuit. I added a 4-channel relay with an octocoupler so that the high voltage and current doesn't come back and kill my Arduino. And I put a PDF of the circuit schematic down in the description for anyone that wants it. But just a heads up, the octocoupler that comes with the relay has to be powered externally by a 5-volt power source. Okay, but with all that said, so I have it set up so that each sensor is like halfway between each coil, and the code that I'm running is set to turn each coil off as soon as I bring a magnet close to it, just for the sake of this presentation thingy. So the sensor on this coil is somewhere over here. Turns the coil off. Sensor on this coil is somewhere over here, hopefully. Turns it off. And the sensor on this coil
turns it off. So I'm gonna bring this party downstairs to test this thing out.
Alrighty guys, here's the setup. I have a 30 volt, 10 amp power source here, DC. And I have the coil gun with the circuit. And I have the code running. So now let's do some test runs. Well guys, that about wraps it up for this video. I think that was a success. I had a lot of fun building this one. But also stay tuned, my MOSFET should be coming in the mail within the next day or so. So my 3-phase DC motor should be up and running in about a week, give or take. But anyway, as always, thank you guys for watching.